Okay, children. So today we will discuss about the activities in periodic classification lesson. Go to page number 84 and activity 5.1. Activity 5.1. Please write down activities. Activity 5.1. This side 5.1 only write down. Please write down the aim to locate position of hydrogen in periodic table. You write full forms, don't write short forms. Okay. Okay, children. To which group and period should hydrogen be assigned? To which group? According to the alkali metals and halogen family in the Mendel. Normally, children, hydrogen atomic number is 1. Children. Hydrogen is atomic number 1. Okay. Its configuration is also 1. Outermost electrons is also 1. Valence is also 1. Children. But please write down, very important. To which group and period hydrogen should be assigned? Many times question they asked. Like metals, you can write this answer. It can give electrons. Like non-metals, it can take electrons. So hydrogen should not be kept with either metals or non-metals. It should not be kept with either metals or non-metals. It should be kept separately. It should be kept separately. It should be kept separately. Okay, but if you come to Mendeleev, children, what is the problem means in Mendeleev's table, all of you see here, children, in Mendeleev's table, what happened means in Mendeleev's table, he arranged elements in increasing order of atomic weights. If you arrange like that in the increasing order of atomic weights, children, hydrogen has 3 isotopes: protium, deuterium, and tritium. Where to keep these three according in 3 different blocks or in same block? It became very much confusion. But according to modern theory, it should be kept separately with children, right? Like metals, it can give electron. Like non-metals, it can take electron. Very, very important, children. Don't forget. Like metals, it can give electron. Like non-metals, it can take electron. So hydrogen should be kept separately. Please write down, children. Hydrogen should be kept separately. Like metals, it can give electron. Like non-metals, it can take electron. So hydrogen should be kept separately. I hope everyone are writing. Go to 5.2 activity. Okay, children. Go to 5.2 activity. When you go to 5.2 activity, write the aim, children. Activity 5.2 aim to locate position of isotopes in periodic table. Okay, children, if you see, what are isotopes? Please write down definition. Isotopes means elements having same atomic number but different mass number. Please write down. Example: chlorine 1735 is there. Chlorine 1737 is there. Please mute your audios. Mute your audios. 1H1, 1H2, 1H3. Okay, children. So, like that, different isotopes are there. So many elements are there. Uranium is there. 92, 235 is there. 92, 238 is there. So many elements have isotopes. Same atomic number, different mass number. According to Mendeleev, children, according to Mendeleev, he arranged elements in increasing order of atomic weight. He arranged elements in increasing order of atomic weight. So isotopes should be kept separate. Isotopes should be kept separate. But according to modern form of periodic table, they arranged elements in increasing order of atomic number, increasing order of atomic number. So all isotopes should be kept at same place. Should be kept at same place, means same block, same box. Mendeleev said we should keep isotopes. He did not understand what to do with isotopes. Mendeleev did not. We studied even in the disadvantages of Mendeleev's, isotopes did not find place in his table. Whereas in modern table, since all of them have same atomic number, all of them are kept in same box. No problem will be achieved. In the same box, all isotopes are kept. Please write down like this. So would you leave them different slots? No. Or would you place them in same slot? Yes. We'll place them in same slot because they have same atomic number. They should be kept in same place. Okay, children. I hope you copied that, children. Everyone, please copy it fast. Next one, children, go to 5.3 activity. Go to 5.3 activity, children. Activity 5.3. What is 5.3 activity? Children, he said inversion of atomic. Four questions are asked, children. Let me answer each question. So what happened is how were the positions of cobalt and nickel resolved in modern periodic table? How to write the answer if this question comes? You should write like this. Modern periodic table, you have tried full form, children, is based on increasing order of atomic numbers. Since cobalt and nickel, this is 27, this is 28. 27 atomic number of cobalt is 27, nickel is 28. Okay, they are kept according to their increasing order of atomic numbers. What happened in Mendeleev's table? They were reversed. Nickel came first, copper came next. Why? Increasing order of atomic weights. No? So somehow problem has occurred. He did that. But here in modern periodic table, they are arranged in increasing order of atomic numbers. So cobalt came first, nickel came next. So that problem is resolved. Why it is resolved in modern table? Because they arrange the elements in increasing order of atomic numbers. How it is resolved in modern table? Because they arrange the elements in increasing order of their atomic number. Writing points, children, all of you. How are the positions of isotopes of various elements decided in the modern table? Okay, all isotopes are of an element. All isotopes of an element are kept in one place. All isotopes are kept in one place because isotopes have same atomic number. So they are kept together of one element. Isotopes of one element are kept in one place only, children. Okay, please write down, children. In exam like this, we should write divide and write. Okay, third question. Is it possible to have an element with atomic number 1.5? Is it possible or no? Means no. 1.5 atomic number is not possible. Why it is not possible? Atomic number means number of electrons or protons. Please keep writing, children. Atomic number means number of electrons or protons. Atomic number means what, children? Number of electrons or protons. So 1.5 means 1.5 electron is not possible. Half electron is not possible. Half electron is not possible. So 1.5 atomic number is not possible. You will have 1, 2, 3, 4. That is called quantization. This is called what? Quantization. Means elements are elements you'll get in whole numbers only, children. You will get elements a half electron, 1/4 electron, integers, fractions, decimals won't come, children, because you'll have 1 electron or 2 electrons, but 1.5 electron is not possible. Where do you think hydrogen be placed? Now only we answer, no children. Hydrogen should be kept separately. Hydrogen should be kept separately because why? Like metals, it can give electrons, and like non-metals, it can take electrons. It can take electrons. Like metals, it can give electrons, and like non-metals, it can take electrons. Please write down, children, everything. Please write down first. So that is 5.3 activity, children. Like metals, it can give electrons, and like non-metals, they can take electrons. So hydrogen should be kept separately. Next, children. Next one. 5.4 activity. I hope you people are able to understand, children. You should understand. There is no other alternate, children. No complex. This is very, very easy subject. In fact, 5.4 activity. Try to understand, children. If you understand, everything will be very easy. 5.4 activity. What did he say? Look at the group one medal is name the elements present in it. Write down the configuration of first three elements. What similarity do you find there in configuration? How many valence electrons are present in these three elements? To write activity aim, children. Aim to study about alkali metals. What are alkali metals? First A group elements, alkali elements. First A group elements. What are the first A group elements, children? Lithium, sodium, potassium, rubidium, cesium, francium. Okay, children. I'll tell one easy idea how to find the atomic numbers. You see, children. First one, this is 3. This is 8. Oh, sorry. One second. 11. Next, this is 19. Always, children, what you do, keep on adding 8, 8, 18, 18, 32. You'll get, children. Okay. So after 19, if you add 18 children, you'll get 37. Okay. After 37, if you add 18 children, you'll get 55. After 55, if you add 32 children, you'll get 87. That's all. 8, 8, 18, 18, 32. 8, 8, 18, 18, 32. Easy method. So children, configurations also you asked, you see, please write down beside that only. Beside this, you should write neatly, children. Beside the activity, should write all this configuration 2, 1, 2, 8, 1, 2, 8, 8, 1, 2, 8, 8, 18, 1, 2, 8, 8, 18, 18, 1, 2, 8, 8, 18, 18, 32, 1. Okay, children. So, what is the similarity is asking, children? What is the similarity? All of them have. What is the similarity is asking, children? Please write down. All of them have outermost one electron each. Because they have one electron, they belongs to first group. They belong to first group. They belongs to first group. All of them have almost one electron, so they belongs to first group. There is asking, what is the question is asking? How many valence electrons are present? All of them has one valence electron. Everyone has one valence electron, so they all belongs to what group, children? First group. Why? Because one valence electron, first group. Group number is equal to number of valence electrons. Please write down, children. Lithium, sodium, potassium, rubidium, cesium, francium. You should remember the elements, children. Lithium, sodium, potassium, rubidium, cesium, francium. You should be in a position to identify the elements and remember the names. This is first group, children. Next, go to 5.5 activity, children. I hope everyone copied this, children. Please mute your audios. Children, 5.5 activity. One outermost electron, so they belongs to first group. If you look at the model periodic table, to study about the second period, children, write down activity 5.5 to study about second period. To study about second period, write down aim to study about second period. What is the period? Second period as well as they give children? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They give children. There you go. Are present in the second period. Write down their configurations. Children first write atomic numbers 3, 4, 5, 6, 7, 8, 9, 10. Configuration children 2, 1, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Alright, do these elements also contain same number of valence electrons? No, valence electrons are not same. In fact, it is increasing. No. Second question, do they contain same number of shells? Yes. They all have two shells. They all have two shells. See children, 2, 1 means two shells. 2, 2 means two shells. 2, 3 means two shells. 2, 4 means two shells. So because they have two shells, they all belongs to second period. So always remember period is equal to what children? Number of shells. And group means what children? Number of valence electrons. Please remember children, all these things are very, very important. Please copy fast. Please go to 5.6 activity children. 5.6 activity. So children, 5.6 activity. Okay. To study about the valency, please write down 5.6 activity children. 5.6 activity to study about valency. Please write down children. What is valency definition? What is valency definition children? Combining capacity of an element is called valence. You should remember children, one more question, board exam they are asking. One combining capacity of an element is called valency. How do you calculate valency? How do you calculate valency? Children, outermost electrons 1, 2, 3 is same. 1, 2, 3, 4 is same. Is same. Their valence is same. Suppose outermost electrons 5, 6, 7, 8 are there. Subtract from 8. Subtract from 8. Subtract from 8. Please write down children. What is the valency of magnesium and sulfur children? Please see here. Magnesium atomic number is 12. 2, 8, 2. Outermost 1, 2, 3 is same. So outermost here how much? 2. So 2 is valency. 2 is valency. Sulfur is 16, 2, 8, 6. Outermost 5, 6, 7, 8. Subtract from 8. So 8 minus how much? 8 minus what you do? 6 is 2 is valency. 2 is valency. Here 2 is frank plus 2. Here minus 2 because they take electrons. Sulfur is a non-metal. They take electrons. Okay. So how does the valency vary in a period? Yesterday I was studying children. In a period, how do valency vary? In a period, how do valency vary? Okay, one period I'm writing children. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, here 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. What is the valency? 1, 2, 3, 4. Here 3, 2, 1, 0. So valency, what is happening? Increasing and then decreasing. Okay, so valency in period increases and then decreases. You should show this example. Directly if I increase, decrease, no one will accept. You should show this example. How does valency vary in a group? Anyone wants to say? In a group, valency is? Anyone wants to say in a group, valency is? Constant. In a group, valency is constant. Why constant? Means I am showing example. Lithium, sodium, potassium, rubidium, cesium, francium. 2, 1, 2, 8, 1, 2 comma 8 comma 8 comma 1, 2 comma 8 comma 8 comma 18 comma 1, 2 comma 8 comma 8 comma 18 comma 18 comma 1. Everyone has one valence electron, so valency in group is same. Valence in group is constant. Please write down, children, all answers. Valence in a group is constant. Write down there, children, what happens to the valence in a group. First, you write constant answer and how will you show. First, write down constant. And what happens to the valence in period they ask? Write down increases and decreases. How if they ask? Show this. Please show this, children. Next, 5.7 activity. Children, you should understand all these concepts perfectly. Then only you'll become perfect. If not, children, always it will be tough only. Always you feel it is difficult. Try to understand what I'm saying. Don't just copy down as it is. 5.7 activity. Okay. Trend of atomic size in, what did you say, group or period they gave? They gave in period. In period. So children, in period they gave one trend. What happens in period, children? They give boron, beryllium, oxygen, nitrogen, lithium, carbon. They're asking you to arrange them in increasing. They're asking what they are arrange them in decreasing order, bigger to smaller. So children, bigger is lithium first. You can check their values they have given. Lithium, then beryllium, boron. Oh, bigger no. Boron, carbon, nitrogen, oxygen. Okay, I told you many times in period, atomic size decreases. Please write down. Why? Reason. And period atomic size decreases because this is children 2 comma 1, this is 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. I told you many times. Shells are same. But if you see, number of valence electrons are increasing. Number of valence electrons are increasing. Please write down why it is decreasing. Number of valence electrons are increasing. Tomorrow question also may come. Atomic size. What happens in group and period? Shells are same. Number of valence electrons are increasing. Nuclear attraction power. Don't write in short form. So I will use 0. Nuclear attraction power increases. Nuclear attraction power increases. Electron tries to come closer. Electron tries to come closer because nucleus will attract. Nucleus will attract. When electrons are trying to come closer, size shrinks. Size shrinks. When size is shrinking, on the whole, atomic size decreases. Atomic size decreases. On the whole, atomic size decreases along a period. Along period. From left to right. From left to right, atomic size decreases. Please write down correctly, children. Because this all you should write in points. Tomorrow, if I ask you exam, please write down, children. This is 5.7 activity. What happens to atomic size in groups and periods is the question. What happens to atomic size in groups and periods? Next one, children. 5.8 activity. Go to 5.8 activity. Please write down 5.8 activity. What is the activity 5.8, children? Okay, so children, 5.8 activity, all those things we'll discuss in next class, children. Okay, so in next class I will discuss remaining activities.